If you like my dad's videos, please subscribe to QA Insights channel.
So I have pinned one link actually to this Clubhouse room. So I'm going to draw some visuals just to understand with better clarity. So please join that link. If you join it, you can see what I'm drawing in the screen so that it will help you to understand better. So no need to register or no need to log in. You just click on that link, the top. It will take you to the miro.com where you can see my cursor and my drawings. Because it's kind of a little bit of mathematics and graph, so this topic. So if you join and see, then you can understand clearly. Thank you. Let us get started. So today we are going to talk about open versus closed workload model. So before we jump into the topic, so this week's sponsor is Redline 13. So if you want to run high scale load testing on your infrastructure using JMeter, please check it out. It's very affordable and it has they have a lot of good features. So and I have another news. So JMeter 5.5, it is going to be released either tomorrow or Monday early. So they have already released the release candidate JMeter 5.5. Monday you will be getting the stable version, the actual official release. So this JMeter 5.5 again, it comes with a lot of features. I already published one post about the open thread group model. So actually it is that we have a coincidence. So we are talking about open versus closed, and JMeter 5.5 gets open thread group model. So I will schedule next week, we will talk about the JMeter's open thread group model to understand better. But if you want to learn more, you can check it out my blog post. So without any further ado, let us get started. So this week we are going to talk briefly about open versus closed. So this topic involves a lot of mathematics and graph visualization. So I'm going to keep it very simple at a high level. So there is no formula, just a concept so that you can understand and then you can plan it and apply with your testing strategy. So as a performance engineers, what we expect to do is usually we have to say what additional load a particular system can support. So that is one question we try to answer by doing a lot of experiments. And next is we try to identify the bottlenecks. And then we will try to get the answer about the impact. So what is the impact on the response time with respect to throughput, and what is the impact on the percentage of errors when it comes to increasing the load. So those sort of mix and match of parameters we try to answer, and then we will try to tune the configuration of the system. So apart from this, we also try to answer the capacity of your particular system. So capacity means how many additional servers we need to support this much amount of load in production, or if the system is over provisioned. So forget about the cloud for a moment and forget about the actual architecture of your application, whether it is a single tier, a multi-tier, or distributed, cloud native. So forget about everything. We are going to see some simple mathematics. So it is not very complex. I'm going to try it keep it very simple so that anybody can understand. So that is why I'm going to draw a few visuals so that you can understand better. So these are the questions as a performance engineers we try to answer, right? And this is our day-to-day job. This is what we do for living, right? But many of us, when we start our career, what we do is we blindly follow some strategy which was set by the previous member, or we refer some books and we might misunderstood the concepts what we read, and then we try to apply, and then we try to evaluate the performance, and in sometimes we may fail. Fail means I have seen many posts or even in LinkedIn messages, my stage performance is good, but in production it is worst. Or my stage is it's worst actually. In production we are seeing different kind of feedback when it comes to monitoring and the performance. So these are the frequently asked questions in any forum, those who are getting started, right? So what is the answer for this kind of situations? That is what we are going to address now by using the open versus closed model. So we are just going to scratch the surface, and apart just using open versus closed, we may not be able to answer every questions. So this is we are just getting started. Probably in after a couple of weeks, I will schedule about the capacity planning. So how you can do the modeling to model your production servers. Everything is mathematics, everything is theory actually. So whatever we are going to see, it's everything completely theory, and we need data to prove our theory, right? So that is why you are going to experiment on your servers and collect the data and apply that data model to these formulas so that you can validate it. So what I'm going to share is just a theory, so you need to apply with your production systems, right? So now let us begin with the open model. So actually I'm not going to call this as an open model. You will understand when we keep going, you will automatically come to know, okay, this is what open model is, and the next one is closed model, so that you can design your test plan accordingly, whichever tool. So these models are tool agnostic. Don't think about it's only for JMeter, only for load runner, only for locust. No, this is tool agnostic. And in next 2 weeks, I'm going to schedule another session that is the architecture agnostic. Whether you have one server or two servers or multiple servers or distributed, cloud native. So whatever the architecture framework is, that still will be applicable. Okay. So first, what we do is, as engineers, as you know, we run our experiments, right? So that is what our first step to understand your application performance and your system resources, everything. So running experiments is a good one. But what if you don't have that privilege, say I don't have enough licenses or I don't have enough infrastructure to simulate millions of loads. So if you do not have those kind of facility advantage, then first thing is you can model your performance of the framework using these theoretical methods. So this will be very helpful. Just with very minimal requirement, you can model your performance. Then once you provisioned your infrastructure, once you have everything in place, then you can run your experiments, then you can match it. Okay, so these are the two ways we can design our performance. Okay, so what we do is first, before we get started, first we need to make some assumptions. So assumptions with respect to your system, and for example, your system should receive the number of requests in a orderly fashion. Okay, so this is your first assumption. Then assume that your system response time is constant. So we are going to keep these two things constant, at least for the beginning. Then we are going to formalize the open workload model. Okay, so assumption is arrival rate, the number of users they come at a regular pace, and then the service time is constant. So if you keep these two assumptions, you can easily model your performance. Okay, but you cannot apply this in your production because production is totally different. In production, we cannot expect anything in order or in a certain pattern, right? So production is total chaos. So don't think about production workload. For performance modeling, we are going to keep these parameters as constant. Next, we are going to assume our application is a single web server. Okay, this is our third assumption. So first is request arrival rate, that is one assumption, and service time is constant, that is another assumption. And we are going to keep our assumption as one single server. Do not think about multi-tier database layers, the downstreams, cloud things, forget about everything. Just a web server. Assume that it's a Nginx. you are running some EC2 instance. That's it. So you are going to hit that URL, it will process, it will give you the response code, whether it's a 200 or 202 or 404, never mind. Just the Nginx, only one instance, very small, you are just sending the request. So think of it like a barber shop, right? So analogy is will help you to understand better. So think of like a barber shop or a doctor's, or if you are going to car wash, right? So wherever you go, what you do is you have to stand in a queue, right? So if the service is busy, there will be a queue. So think your barber shop as a server, and you are a request. Think of like you as a request. So if the request comes, if the server is busy, what the server will do is it will queue the request. So that is the we are going to assume that okay, there will be a service. Before the service, there will be a queue. So if the one queue comes, if the server is busy, then it will not take the request. It will keep the request whatever it is serving. Once the service is done, then it will accept the next request. Okay, very simple, nothing complex here. So we are going to use this single server model to understand the open workload. Okay. So now our next question, okay, what is the maximum throughput of the server? So throughput means you can say a request per second. Don't think like a load runner terms or any tool terms, because each tool throughput definition is varying. So in this case, our throughput is we can say requests per second, basically some tasks over time. Okay, so requests per second is our throughput. So we are going to identify what is the maximum throughput. So this is our first question we will ask as a performance engineer. So next question is how we can improve the service time. So service time means how a barber can improve the service to the customers so that the queue will be very less or shortened, right? So instead of using manual scissors, what he can do is he can bring something electric device so that it will speed up the shortening the hair, right? So by implementing the electric device, he can definitely reduce the queue length, right? So similarly, there are multiple ways where you can reduce the service time of the server. For example, you can put some say caching, or you can put some queue length, maximum queue length, or you can have something like a circuit break, right? Short circuit break. So if the request per second is overloading, then you can just say I'm already busy, so please try again later. So something like that you can implement so that you can improve the service time. So we are not going to talk about the service time. So we are going to talk about only the maximum throughput. What is the maximum throughput and how we can improve the mean response time, right? So now what is service time? That is our next question, right? So there are Little's law is there. Again, everybody uses Little's law, but they do not know what is the purpose. Without that, I have seen people, they bring up Little's law. So Little's law is irrelevant here in this context. So our service time is nothing but queuing delay and plus service time equals response time. So if the barber is taking say 15 minutes, right, for one person, then it including the delay and the service time. So this is the response time of the server. So this response time basically it is directly proportional. Directly proportional to what? That is our next question, right? So this response time is directly proportional to arrival rate. So if you keep adding the requests, what it will do is definitely it will increase the queue. So if the queue is getting increased, your response time also will increase, right? So this is our theory, but there is a mathematical formula for behind this to validate this theory, right? So for example, if a manager comes and he is giving more tasks to you, so what you will do is you will take more time, right? The more time it will take, the more time it will take you to done for the day, and you will easily burn out. The same concept. So if the request is coming too much, then the service will take its own time to serve. So that will increase the queuing response time as well. So everything is directly related. So some component is increasing, definitely it will increase the other parameter as well, right? So now this formula is called PK formula. So it's a Polak-Kleinsin formula. So if you just Google this formula, PK formula, you will come to know about the impact of this queuing delay and then queue length and waiting time. So everything you can see it clearly in this formula, PK formula. But apparently we don't use this formula, but indirectly we don't use it, but it has a direct impact in our performance modeling. Okay, so now I'm going to draw one diagram in the Miro. So if you don't join, please join. I have pinned the link so where you can see my visuals. So I'm going to draw two axes. So okay, there is an x-axis which is the arrival rate. So arrival rate means it is the request per second comes in a certain duration. So I'm going to increase the font. So arrival rate, and in the y-axis the utilization. So there are a lot of assumptions we have to make here. Okay, I will go one by one. So utilization usually it ranges between 0 to 1. Okay, so 0 means the server is not busy, 1 means server is busy. Okay, so always if you see these formulas, utilization it always either between 0 to 1. So it will not be, don't think of like a CPU or memory utilization where we mention in a percentage. So utilization in this context is between 0 to 1. So 0 means not busy, 1 means busy. That's it. So now if the arrival rate increases, utilization also will increase, right? So how it will increase is basically it will linearly increase. So if the arrival rate is 10, utilization will be say 0.5, and arrival rate is 20, utilization will be like 0.75 and so on. So this is the first thing you have to understand. So there is nothing like a rocket science here. Simple. So arrival rate increases, your utilization also will increase. If the utilization increases, the queuing delay also will increase. So everything is directly proportional. So any questions till now? Please raise your hand so that I can admit to the stage. Okay. Okay, now let me just bring the PK formula here. So PK formula, again, the purpose of PK formula is to find the response time. So in this pattern, so right now we have arrival rate and utilization. So what will happen to the response time? That is our next question. So we didn't talk about response time, right? So we have to talk about, we have to derive something so that you can understand the response time in this context. So response time, it will increase, but in what fashion, right? So we cannot say directly proportional. That is why there is a formula, PK formula. So if you apply the PK formula, I will draw one more graph. So in the x-axis, in the y-axis, we will have a response time. And in the x-axis, again, we have the arrival rate. Utilization. So here we are going to apply the PK formula. Let me just put PK here. And in the y-axis, we have the response time. So response time has many names. Think of it as a latency or residence time in mathematical zone, right? So it has many names, but in this case, let us call it as a response time because we will use this term across in our day-to-day job. So this particular graph, if you apply the PK formula with the utilization, service time, waiting time, everything, the graph will look like this. Let me draw it quickly here. So this is how the graph will look. Okay, so it is not linearly scale. It will scale like a hockey stick. So this curve is called hockey stick in mathematics. So this hockey stick curve only you will get even if you test your application today. So take any Nginx, just deploy, or you can use a Docker, or you can run something locally on your machine. take JMeter and then increase your throughput, say 5, 10, 20, 25, right? So if you keep increasing, your response time also will increase in this fashion. So it will not be linear. Okay. Any questions till now here? So please raise your hand if you don't understand anything so that I can explain it better. Okay, so if you apply the PK formula in your system, this is what you get. So response time will increase like a hockey stick for the open model. Okay, so if your system is open, okay, if you apply, if you run your tests against your throughput versus response time, you will get this graph. Because I have done this, I tested this. Yeah, it is working. Locally also I tested, my application also tested. So this is what I see. Okay, so most of the application we work is a open workload model. Okay, Amazon, any website you open, right? That is an open workload model. Any e-commerce websites, so open workload model. Newspapers, websites, blog articles. So everything, most of us, we interact with open based systems. Okay. If you are getting something else, then you are doing something wrong with your strategy. That is what my main point is, because we do not know what kind of strategy we are using, and we give different kind of graph, and we are testing something else, and the expected production is totally different, right? So Monday, please do this exercise. It will not take much time. Locally, if you deploy, it will be you can easily get this graph pretty quickly, because local utilization is very fast. It will increase it because you are running locally, but you will be able to get this graph. Okay. Next, how to find the bottleneck, right? That is our next question. The maximum throughput. That is our the interest, right? So again, let me just change this to utilization to TPS throughput. Okay, and assume that there is an SLA in your system, right? So SLA everybody has. So SLA, say for example 3 seconds. Okay, 3 seconds. Then what is the throughput? What is the maximum throughput of my system, right? So the y-axis is response time, and throughput again in x-axis. And if the response time anywhere it is crossing 3 seconds, that is your maximum throughput. For example, assume that it is crossing here, because this is where the upper the curve is bending straight, right? So this is your throughput actually. So let me just draw it quickly. So this is your throughput, because this is where it is where it is just linearly it is going up. I mean not linearly, just straightly just shooting up, right? So this is your maximum throughput in this zone. So this is called high utilization zone, this particular zone, and these are the low utilization zone. So if you run with this throughput, or you can just keep it here, or wherever you want to, wherever the SLA is breaking, right? Just keep the curve line there. So these are low utilization and these are high utilization. So this is how you figure it out, the maximum throughput of your server. Then what you can do, you can vertically scale or you can horizontally scale. Then you can run the test again and see where it comes, that the curve. So you have to keep doing this again. That is not the way it works. I will explain why in future. But this is how you evaluate your server as a single server. This is a single server model. The app name, it's called Miro.com. I got one question. So it is there in the Clubhouse, the pinned link. So the same hallway, you can see at the top, there is a link, Miro.com. You can just tap that link, you can see it. Okay, so this is the open workload model. Okay, now I assume that you still don't understand. I'm assuming when we talk about closed workload model, you will clearly see the difference what I'm talking. Okay, so now I'm going to now we are moving to closed workload model. Okay, so let me just move this objects to the top. Okay, okay, so now the closed workload model, how it works. So think of it like a, say, Google Photos application in your mobile, right? So everybody has some kind of photo uploading app, right? For example, you could have OneDrive or Dropbox or Google Photos or Google Drive, something sort of some storage application, right? So what it will do is whenever you take a photo, or whenever you have something have some document in your local mobile, what it will do is your application will pick that up and then it will upload automatically, right? So this is how the application works. And if it is a, suppose if there is a setting like, okay, upload every 1 day or upload every 1 hour, some sort of settings will be there, right? So what that setting will do is, so every 1 hour it will check anything new in your mobile, and if there is a something, it is if it is there, then it will upload that file to the cloud, right? So in this, think of like a model. Okay, there is a client and you are sending it to the server, and the server is giving back some response to you, and then it will sleep for certain time, then again it will upload something, and then the loop continues, right? So here in this model, what we are doing is we are creating some kind of a closed feedback. Okay, so let me try to draw it here so that you can understand better. So let me grab the pen. Okay, so now say we have one server, a mobile. Okay, this is the mobile app, and we are just sending a request, and this is our model, the system. So you are uploading some files, and then it will process it, then it is giving back the response to you. Then there will be a sleep time. Okay, there is a, let us say, sleep here, and then again once the sleep is done, again it will upload, then the server will process, again it will give back the response. So this loop will keeps going till something happens, till it terminates. So it's like a, say, while loop, right? While true, upload something, then sleep for 5 seconds, then again upload something, sleep for 5 seconds, right? So this is called a closed feedback. So closed feedback means this system follows the closed workload model. Okay, so this closed workload model is we are using it daily. Okay, anybody can answer that? We are using it daily. So do you know any tool which is using the closed workload model by default? Anybody can guess it? So daily we are using this, actually. This tool we are using it daily in a closed workload model. So any tool, any guesses? Actually, it's our performance testing tool. So all the performance testing tools heavily, the design wise, heavily relies on the closed workload model by default. Okay, I'm talking about by default settings. Okay, if you take a load runner, if you open controller, if you design something, by default it will plot the closed workload model. If you open JMeter, create a thread group, run your test, that is closed workload model. Any tool by default, closed workload model. There is a tool called StormForge. I don't know how many of you heard about this, StormForge. So this tool supports by default open workload model, but they support both, but their favorite is, I mean, their priority is open workload model. Okay, so JMeter supports both the workload models, we are going to see, and load runner also supports both the workload model, but by default whenever you run something, it has the closed workload model. But we do not know, without knowing that, we are testing it. That's why we will see some difference with respect to performance in production with respect to stage or non-production. So we cannot use a closed workload model for the open system or open workload model for the closed system. If you use it, what will happen? You will get different graph visualization, and you will miss a lot of things if you mix and match these workload models. Basically, we are doing it totally wrong. Okay, so now I will explain how the graph looks for the closed workload model. Okay, so we have plotted the throughput versus response time, right, for the open workload model, and now we are going to I'm going to talk a few laws. Then we are going to see how the graph looks for the closed workload model, so that you can understand even better. Okay, now let me just delete these these objects. Okay, so now, okay, since we talked about this closed workload model, right? So closed workload model is the synchronized model, other name. So all the requests are synchronized, right? Synchronized means what? You are sending a request. Till that request gets a response, there will be no more. There will be no. Eventually, there is no another request will kick off. For example, you say in JMeter we are sending 3 threads, and if the 4th thread is trying to inject, no, it will not work. All the 3 threads being served only, it will take the another set of iteration, right? Because it's still processing. The request is still open. The server is still processing that request. You cannot just put another thread and send a request. No, it will not work. It will halt that particular thread. So it keeps closed, and this is called synchronized nature, right? But our application, our whatever websites you use, right? Those are asynchronous basically, because at any point of time, any direction, any user can come to the system, right? So that is why we should not use it. So we are going to see in detail. Okay, now to understand the number of requests or number of client or number of threads, whatever the number, right? We are trying to see, and what is the response time. So we are going to talk about the famous law, Little's law. So Little's law gels with closed workload model. Okay, it will not gel with the open workload model. So whenever we see about Little's law, it is a closed workload model. So Little's law, everybody we know, right? So throughput multiplies by service time. So service time including the think time, right? So if you increase the client, again it is directly proportional to the throughput. So that is why we derive the n value, and then L or L, whatever the name character denotes. Then we test our we design our workload model. So now we have to understand how the graph will look when it comes to the response time, because here we plotted response time versus throughput, which is hockey stick curve. So now I am going to draw, after applying some formulas. I am not going to detail in the formula. So now again in the x-axis I will have say throughput, and y-axis is the response time, right? Or we can say instead of throughput, what we can do is say n number of requests or n number of clients, whatever. So here you can say clients. Okay. So now the response time, how it looks is like this. So these are mathematically derived. So response time will look like this. So when you use a closed workload model, if you run your application, you will get curve like this. So it is totally different than whatever the curve we have got in the open workload model. So it is actually just going up high in the early stage itself, if you see here. But in the open workload model, it is taking time to scale, then it is shooting up straight vertically. Okay. Okay, now we have talked about response time and the client, right? So what about the throughput? That is our next question, right? So throughput. So throughput looks totally different. So let me plot it and explain. So in the y-axis, again, we have throughput. And you can say this is arrival rate, or so this should be, yeah, right, yeah, it's arrival rate, I guess, yes. Arrival rate, and this one is throughput. Okay, now your curve will look like this. For the closed workload model. Okay, so why the curve is looking like this, I'll explain. Say the number of clients are increasing, number of mobile devices are increasing, or number of users are increasing in a particular system. So if the throughput is increasing, since it's a closed model, what will happen is it will increase the queuing delay, basically. So the queue will increase, but the service time will stay the same. Okay, in a closed workload model, because all the requests are synchronized. So if you increase your arrival rate or increase your the number of clients, the throughput at some point of time it will flatten up, because the system can handle only certain throughput only, right? It will keep up the service time, but the queue will increase. So at some point of time it will the throughput will be constant, but the queuing delay will increase. Okay, so if you have something like a closed workload model, your throughput will reach at a steady point. You don't get any errors, basically. Okay, so you don't get anything with respect to increase in the throughput. It will not scale up. It will just keep it constant after a certain time, but the response time will shoot up drastically. Then it will you will get a lot of failures. Okay, so by comparing these two graphs, you can easily figure it out. Okay, when your server is breaking for the closed workload model. Okay, if you have a SLA, you can easily figure it out. So just plot a graph. Okay, where it is you are getting more errors, and then where the response time is violating. So just draw a line, and again correlate with the throughput. Then you can figure it out. Okay, which throughput the system is, and what is the response time, and when it is breaking. So this is the open versus closed workload model. Basically, simply if I put, open means whenever you have the controlling the throughput, RPS, that is the open workload model. Whenever you control the number of threads or number of users, that is the closed workload model. So by default, everybody uses closed workload model. We are not supposed to. We have to use the open workload model, because most of the applications we test is nowadays open workload model. Again, you have to take the call by running some tests, or you can ask the development team or architects team, okay, what are we following here? So what is my scope? What are we following? What kind of model we are following? Because I have seen some systems in the front end it will be open, but in the back end it will be closed. There could be there are architecture like this, right? So again, you have to take a call. Okay, what is my scope? What we are testing, and what model it is falling under. Then you can evaluate your system, find the throughput, find the response time when it is breaking, and those things. Again, this model is for single server only. So we have not talked about anything multiple servers or the distributed nature. Any questions, guys? Jacob, sorry, could you please enter the stage so we can discuss?
I assume you can hear me already.
Yeah. Hi.
So I noticed that the chart that you've presented for the PK formula exactly for open versus closed. That to me looks just like an inverse. If you could swap the throughput and arrival rate drawn like this right now, they would be pretty much the same
Which
in terms of
graph you're talking, Jacob?
I'm talking about the both charts on the right. So the ones under PK formula.
Not the top. At the
The
top
top
graph.
right and the bottom right.
No, 1 second. Okay, I'm just marking it here. Is the graph you're talking?
The one on the right. The one on the right. Not this one here. Yeah, this one here. This one and the one on the bottom. The one below.
Yes. For the open workload model, you will get a hockey stick curve. For the closed workload model, you will get the graph like this, like a inverse hockey stick, you can say.
Because I see the throughput there is on a x-axis on the one and then on the y-axis on the other.
Correct. That's correct. Yeah, because here we are talking only about throughput and response time. Here we are talking the arrival rate and the throughput.
Okay.
Yeah, because each model works differently. But as a performance tester, we have to make sure we are using right model for the right system.
Okay, thanks.
Otherwise, we get something else, and in production, it will have another impact.
Yep, sure, answer. Perfect, thanks.
So those who joined new, please join the Miro.com. The link is in the hallway at the top, pinned link, so that you can see the graphs. So any questions, guys, here? No questions? I thought I expect a lot of questions actually.
I mean, from the say report perspective, it would still manifest itself as a delay, as an increase in response times, right? Regardless of the model we be using with our workflow.
Correct, yes.
Okay, yes. And there's still going to be a chart of the throughput over time that is going to be limited at some point, right?
Correct, yes. Yeah, we'll hit a bottleneck. But yeah, what kind of curve we are getting, you have to watch out for that.
Yep.
But this is just a graphical visualization. I mean, it doesn't depict, like this. There will be some kind of outliers will be there. Yeah, you can probably deep dive into the white outlier, or you can just ignore the outliers. But overall, if you just plot it, you will see this pattern.
Okay, yeah, thank you.
Okay, and do not use a logarithmic scale in your x-axis or y-axis. So that is a bad way of representing the graph, because if you use the logarithmic scale, the pattern will change. So do not use logarithmic unless it is required. So that's a bad way of practicing. That's what the statisticians say, that logarithmic scale, you should not use it. Okay, so these formulas, again, this is very decade-old implementations. Okay, the statistician called Erlang. So he's the one who first researched about this queuing delays. So he was working for Copenhagen telephone system 100 years ago, 110 years ago. Just to understand, okay, how many connections we need, how many telephone systems we need, what is the wait time for the particular number of users. So how many systems we need to have to serve the customer base. So those questions comes up, then he formulated the base. So after a few years, many research scholars and statisticians, they improved further on this formula. That is why we have PK formula, Little's law. So those things helped us in understanding how the queuing works. And after IT revolution comes up, so we just grabbed the concept from mathematics and statistics, then we implemented it in our architecture. So all the formulas, it is proven actually. You can run your test and then you can see, you can match it. And even the universal scalability law, which we are going to talk next week. So thus that universal scalability law helps you to plan your capacity of your servers. So the inventor who created is Dr. Neil Gunther. You can just Google. So Dr. Neil Gunther, he used Little's law and other formulas, and he derived the scalability law to understand how the system scales. So that is how the Facebook, Twitter, Google, all the systems, the base is universal scalability law. That is why they are able to scale up to millions of users. But the base is universal scalability law, which we are going to see. It is not, I mean, it's very complex topic, but I try to keep it very simple so that you can apply the formula and then you can see how you can design your systems. Okay, any questions, guys? So that USL is again, it's a framework agnostic. So you can apply it for any architecture. So that's the beauty of that law. There are a lot of white papers are there. If you're interested in reading white papers, if you just Google, you will get a lot of white papers. It's free only, free to download. You can go through that. So all the white papers, they have some of the white papers I have seen JMeter and the load runner. They compare it with a lot of different flavors of the system. So mainly that's what the gist of it. People are the testers or the engineers might be using a different model to test the different aspect of the system. They might be using other way around most of the cases. So it is our responsibility to follow the right model for the right system. So your graph should look like this always. So whenever you run your test, let me just quickly combine these two. So your graph, either it should look like this or like this. If you are not getting this pattern, then there is something wrong. Okay, so your y-axis is response time and x-axis is your throughput. Let me write it here. Throughput or TPS, whatever you can call. So here it is response time. So if you plot response time versus throughput, the graph should be like this, hockey stick, or it should scale up pretty quickly in a linear fashion, almost linear fashion. Okay, if you're not getting this graph, then something is wrong, something you are missing. If you get a graph like this, wrong, right? Or if you graph like this, wrong. So run your tests and see whether you are getting the either one pattern. So please raise your hand if you have any questions so that I can address. So actually I have not given any formulas, because formulas, I know people it will get bored. So I'm not writing any formulas. So I'm just grasping the formulas and then I'm just trying to explain in a visual format. So just keep it in mind, in a closed system, throughput will reach at a certain point, then it will stay. Okay, in the open system, it will just scale up pretty quickly. So whichever graph you are plotting, please pay attention, otherwise you might miss something. And then there is another formula, another law called Amdahl's law. So again, I'm going to talk about Amdahl's law in next session. So that also will be very helpful. Actually, that also USL uses Amdahl's law as well in that formula. So Amdahl's law, you can just Google, you can easily get the grasp of it. But I will try to explain in a very simple way. So there are a lot of laws in place. So just like since we are little size become famous, we should not blindly follow that only. Based on your system, you need to pick up the law, and then mainly you have to experiment. So this whatever I explained is theory part. So mainly you have to run your test, then try to match it with the hypothesis. So you form the hypothesis, then you do experiments, then you try to prove that hypothesis. So that is how it works. Or if you have a luxury in like a Neuralink tool or Dynatrace, go to your production system, take the throughput, take the users, and take the number of machines or number of CPUs, number of nodes, whatever, just plot it. You will easily see the graph of USL. If the properly system is designed, then you will see the USL. Again, I will show you the next class how the USL graph will come. So you will get the USL pattern. So any questions, guys, please raise your hand so that I can admit to the stage. Hi Jagan, thanks for joining. Hello? You're
Sorry,
not audible,
audible?
Jagan.
Yeah.
Yes, you are audible now.
Thanks, Naveen. Sorry, I joined late, but I understood the topic and especially this work closed work model, right? The open closed work model.
Yes,
I was primarily currently working on the load design because in a K6, right, we got iterations, right? So that iterations, like we have a uh, constant arrival rate, right? That iteration helps to create that closed model.
okay.
Uh, yeah,
So
that's
your
my.
system is closed workload, you mean your system is closed model?
Well, I haven't studied on that.
Okay.
So now only I learned from your side, right? Like the formulas. So I have to go and I have to study the current prod to understand what is the current model in that my application. So I
Yeah,
have to take the steps accordingly.
sure. Yeah,
Thanks, sir.
mostly, yeah, we'll be working in open. Closed is kind of, yeah, we can say 80-20 percentage. 80% we'll be working in open systems only.
Yep.
Okay, guys. So if you don't have any questions, we can wind up today's session. Hi,
Hey,
Sid.
hey,
Hi, Sid. Yeah, please go ahead.
sorry, totally missed 70% of thing I missed. I was driving, and just now, at the end, I could able to hear something about the graph. So I have a few basic questions, like this open and closed workload model. What phase of performance testing life cycle it will come? That is the first, and yeah, you said it's not too like elastic, right? That's
Yes.
fine. And who will decide, and is there any white paper? Anyway, I have to rewind your this podcast again, that I'm going to do now. Yeah, these are the things.
Yeah,
Any
there
white
are a
paper
lot of
from you or video?
yes are there,
Okay.
but it's very we have to read multiple times to understand the concept. So I tried two white papers. Mainly because it talks about load runner and JMeter as a example and how they did the experiments. So those white papers will be very helpful to understand the logic. Okay, why we need to care about the workload model. So how people are doing it wrong, right? And how the graph will look in production, and how to design your experiment. So those things are there in white papers. But yeah, you need to.
Speaking of which,
Yeah,
sorry to
yeah.
interrupt, Naveen. So, speaking of which workload model, right? So, we have always faced two kind of, in general, if its app is new, that's another scenario, and if it's going to freshly to the prod, that is a scenario. And existing ones, and if you are remodifying or anything, that is a second thing. So, as a requirement phase, when we are designing a workload model, so you think this is we have to is it on which perspective we have to see this open model or workload model? It's server specific, right? not to the tool.
Not the server actually, the design specs actually.
Which
The
design? So
architecture
you are
design.
talking about our.
Yeah.
Okay, so it's completely the app
Yes.
related, not
How the
tool
request is
related.
processed, right?
Okay.
So if the
Okay, that
request, for
makes sense.
example, if
Okay.
you go to any auction related websites or any websites has a deal, right? And then you have some time, right? Say Ticketmaster. So if you go to Ticketmaster, initially it will be open workload model because anybody can log in, anybody can get into the system. But once you're trying to book for a show, it will lock you, right? 15 minutes, within 15 minutes, you have to check out, right?
So you call that one as a
Closed model,
closed
yeah,
one?
kind of, yes.
Oh,
So that's what,
okay.
it's a blend of both you might expect in your application unit test. So that's what, which component you are testing. Whether you are testing end to end, then that would be a little tricky because which workload model you have to follow, that is a question mark. But if you talk about, we have multiple components, right? We have a load balancer, then we have a web server, again app server,
So that means 90% of time we are testing in a closed
closed
mode.
model, because
So
our
we'll be
default,
never
yes,
open.
because the tools nature. Okay, nothing as a
Got it.
performance engineers. That's what we miss it. It's a hindsight. It's a blind mirror, right? So by default, whenever you
Yeah.
run using any tool, it has the closed nature.
Yeah.
So
Yeah.
yeah,
Most of the tools.
you
Yep.
have to
Most of
change
them.
it. You have to change the type. So you have to focus on RPS instead of threads or users. And then you need to plan your workload accordingly. So likewise, as I said, right, Ticketmaster, if you go into system, 15 minutes only. Every 15 minutes, there will be a checkout. There might be a checkout from set of users. So if there is a threshold limit reached in 15 minutes, then the users will be kicked out of the queue. Right?
Okay.
So think
Okay.
of like a
Any
barber shop.
auction, any release,
Yes.
yeah, any release. If Apple is product in, suppose example, Apple is getting a new phone and they are giving to only limited number of users to book. So that kind of situation you're
Correct.
talking about, right?
So every 15 minutes, the
Okay.
system will
Okay.
process your orders, checkout orders. So that is a closed
But
workload model.
don't you think that kind of situation they already pre-planned, resources? They know, right?
That's what, as an engineer, we need to
Okay.
test with the right model.
Yeah,
Then we
got
have
it,
to
got it.
validate
So
with
to
the
test that
production
kind of
performance.
innovation, so do you think we can use the almost proper, famous tools like Neolo or JMeter,
Yes.
Load Runner for that kind
Yeah.
of situation? And
All the tools supports both the flavors.
okay,
That's
okay,
what we have to see
interesting.
which flavor you are going to design your test. So that is
Yeah, yeah, makes sense.
our responsibility. So we cannot just okay, thread group, okay, run it. Then you will be testing Nginx server, which is an open model, but you are testing in a closed fashion. Then the results will be different in production and in your stage.
Yep. But yeah, like you said, the closed model very rarely tested
Correct.
scenario, right? Yeah, got it. Thanks, Navin. So now it's clear
Yes.
clouds, and I'll go ahead and
Yeah,
explain.
that's
Yeah,
what the
thanks.
graph we should get like a either two, whatever I draw it here. So this is the right graph.
Oh, let me look into the graph. I haven't
So
looked at
other
it.
than
Yeah.
any pattern, if you get, yeah, you need to redesign your plan
So the graph you're talking about the
versus
RPS
TPS.
related to the server, it's like a load balancer, or like Nginx,
Yes,
right?
open model is, yeah, web
Web
server.
server.
Yes,
Yep. So what the graphs? I couldn't able to load it, but it's still loading for me. What is it? Parabola or hyperbola? What
no, the
graph you're able to load?
leftmost one I have driven. I mean I drew. So this is the
Okay.
tick mark which has, right. That is the pattern you should get.
Okay.
I can
Okay.
say put it like this. This one green color. So this is the one. So this link will be available. I'm not going to delete this, so you can refer this any point of time.
Yep. Then. And why don't you make a like a short like paper white like white paper kind of stuff?
White paper is already
One
there
page.
on this. Many people already wrote. I mean, many
Oh,
experts. I'm just a small guy. So yeah, probably I can come up with some article. I can try to.
okay. Okay. Cool. That's what. So it will be easy.
Okay, yeah. So thank you everyone for joining. Yeah, please let me know if you have any questions. Next week we can see about the capacity planning and how you can leverage the universal scalability law. Actually, this whatever we see open versus closed, that is the basis to learn more about the capacity planning. That is why I brought this topic first instead of directly jumping to capacity planning and universal scalability law. So if you understand this, you can easily understand the capacity planning. So if you do not know this, then it is very tough to digest. That's why I brought this topic first. Okay. So next week we will see about that universal scalability law. And thank you for joining and have a great day. Thank you. See you. Bye.
Yeah, thanks, Naveen.
Thank you.
If you like my dad's videos, please subscribe to QA Insights channel.